Hey, so I'm Abhinav and I will be presenting my project Multi-Genre MusicTransformer, and we will compose full-length musical piece using this transformer. So talking about different ideas of creating music artificially involve different kind of networks. One of them is GAN. In GANs, what we do is that we create adversarial variations of the music, and these GAN networks are basically learning latent features from rhythm and bar. Then there is semi-supervised learning. So what we do is that we mix different stems of music, and then depending on their harmonic and vocal features, we supervise whether it's a good or bad music. Then there is transformer, where we treat music as sequence of events and then predict them sequentially to create music. So starting from GAN's network, one of them is Muscan, and what we will identify by end of this slide is that these are monotonic. So what GAN does is that it will represent rhythm bar instruments as latent features. Then it will produce adversarial samples of the original music. But these musics are similar to the old ones and it generally lacks freshness. Next is mashups that we create using mixing different stems of music. So we take different stems like vocal, drums, and then depending on key and tempo features that our network learns, it will mix these different stems and will label them as either good or bad. But our music all about mixes. Secondly, these are really slow to train. Now we will talk about treating music as musical events. We want to predict sequence of these events to represent music. And these musical events can be combination of different tokens occurring together. So what are these tokens? These tokens can represent different musical attributes like chord, tempo, pitch. Now what our transformer will look like. So what a transformer does is that it will take these different type of tokens, embed them so that we have a transformer input. And now our input will use these tokens to learn sequential features from them and then predict these learned features from the sequences to predict new tokens simultaneously. And then we will group these tokens again to represent a new musical event. And then for this musical event will be one unit in our sequence. And then we will keep on doing this process to create an entire sequence of our music composing. So how to make a transformer a multi-genre transformer? For this, what we need is a multi-genre data set so that our transformer has a diverse environment to learn from. Then once we have this data set, we need to build our dictionary of tokens so that our transformer understands the vocabulary it needs to predict. So talking about our training phase, what we did was that we trained our model in two different data sets. One was pop dataset and the other was multi-genre dataset. And then we trained for around 17 hours using a 9.8 GB GPU. And what we observe is that for each of these tokens, our loss is converging, which shows that our transformer is actually learning to generate music. Now, comparing the results, what we see is that each song has an inference time of around 12.5 seconds. And then we have around 9,000 tokens for each song that is produced. And if we compare the piano rolls of a original song like Alan Walker and then any song that we generate from our transformer, we see the piano rolls are rich and they have diverse transcripts. Let's see what are the take home messages. First, to solve the music generation challenge, we treat musical piece as sequence of musical events. Then we treat different musical attributes as tokens. These tokens can be pitch, chord, bar beats, which our transformer will learn. We can also define any new or more complex tokens like chord progression or art form to our transformer so that it learns easily. Then the idea of grouping tokens to represent an event can be used something that is apart from music, like pollution index. Then what we see is that transformers have a good feature of learning long-term dependency in sequences, and then these are faster to train as well. Now let's see one of the musical pieces that we generated from a transformer. That sounded quite good. Thank you.